Hello everyone and welcome to a new video on this channel. And this time we will build a small application, a sample application that combines the Azure Function programming model with something which is also relatively new, which is dapr. We'll take a look at these two components, how they can be used together, and we won't discuss in detail before we start with what these components can do, what these systems can do. We'll just explain as we go along based on the example that we're building. Just in short, what's the example about? Well, we have an IoT Hub in Azure which has incoming IoT messages, simple JSON based messages. The Azure function that we'll write is using a trigger, an event hub trigger, to process these messages as they come in. And then based on the contents of the message, like for example, the temperature is too high, we will send out a message on a PubSub topic, and we'll use the dapr subsystem or the dapr system to make that easy for us. So basically, we're using the Azure Function programming model to hide the complexities of working with event hubs, and we'll use the dapr model to hide the complexities of doing PubSub with some kind of PubSub messaging backend that we don't really want to be busy with. Let's see how this works and how to make this all happen. So first thing we have to do is, and I have actually a README MD for this, so we can use this to follow along. And I'll make this a little bit bigger as well. Yeah, of course you should get started with these things first. First of all, you have to know a little bit about dapr, so just go to dapr.io to find out more about what it is. But an important thing I want to call out is the following one here. If I click on this and open it, you will see that actually not that long ago, I think before July, I think end of June, maybe beginning of July, there was this Azure Functions extension published, which basically allows us to use the Azure Functions programming model with the dapr subsystem. So there are all kinds of, it's actually an extension for Azure Functions that provides you all kinds of bindings and so on to work with dapr. Yeah, even in an easier way than it is to use dapr, because dapr is easy to use as well without Azure Functions. But you'll see in a moment how that actually works. But for sure, this is an important thing to understand. So please also read up on this section. Now, what you need to get started is, of course, first of all, you have to have dapr installed on your system. In a later video, we'll use dapr on Kubernetes, but in this video, we will use dapr on the local system. So you have to have dapr installed locally and configured locally. And you just run dapr init to get that to work. You'll need the Azure Functions core tools to develop Azure Functions locally on your machine. Docker is required, especially by dapr, as you'll see in a moment. We also need the .NET Core SDK to integrate dapr with Azure Functions, but it's not by default the case today. It's too new for that. And you also need Node. Well, if you're going to use the sample I'm using, it's JavaScript. We're going to use Node for that. Now, before we get started on the example, indeed you have to have dapr installed. And by the way, I'm using the Windows subsystem for Linux 2, so WSL 2. And of course, yeah, dapr to install it, go to dapr.io and find the installation instructions to install the dapr executable on your system. You can also run this on Windows if you want. And the dapr command, once it's installed, it has a dapr init option, and that initializes dapr for use on your local machine. Now, I already ran this, but I can rerun it. It's no problem. I might see a small error like, yeah, indeed, could not delete the data file. That's fine. So it's setting up several components. One of those components or several of those components use Docker. So if I'm doing a Docker PS, you'll see that we have a dapr.io/dapr image which is run, and also a Redis database is run. And they were just started a couple of seconds ago because I ran dapr init on my system. Just to point out, Redis here is used to provide things like state management, but also the PubSub functionality. So to make it easy to do PubSub on your local system, Redis is automatically used, and we will use Redis for doing this PubSub as well. So what you're seeing here on the graphic is that indeed with Azure Functions, we'll ask dapr to publish a message on a topic, and the backend system that receives these messages and where others can subscribe to is indeed Redis, and dapr is using Redis streams to get this all to work. So not a regular key value pairs and so on, but Redis streams is used for the PubSub functionality. And there's also something again here. dapr is using some, let's say, sane defaults, or make some choices for you in how the backend stuff is implemented. So in this case, I don't have to know anything about Redis. I don't really have to know anything about Redis streams either. I just have to know how dapr implements this functionality, and that's basically it. All right, so we did that. So let's now go to our preview here. We have all the things taken care of. Yeah, let's first create a function app. So I'm going to make that very brief, because that's quite easy. If you have worked with Azure Functions before, I just went to a folder called process. Within that folder, I could either say I'm going to do F1 in VS Code and create a new project. What I can also do is I can just do func init, and I use -- docker to also have Docker files generated for later if I'm going to bring this to Kubernetes. That's fine. Either way you start it, you will get some questions like, what's your function called? In my case, process messages. What's the language runtime you're using? In my case, JavaScript. And what's the trigger? How does this function get executed? Is this just by HTTP request, or is there something else that triggers a function? In this case, we could select an IoT Hub trigger. But you'll see in a moment that an IoT Hub trigger is actually using an Event Hub trigger, because an IoT Hub is using an Event Hub in the backend to deliver messages to applications that request it. So we'll see in a moment how that works. So func init resulted in the function being generated. So what you can see here is I have the process message folder with the name of my function, and then we have an index.js, which is the code of my function. We'll see later what this code is all about. It's kept explicitly simple, because this is not a video about coding. It's more about, okay, how do you use these two programming models together, right? And of course, my function also gives me a function.json. Initially, when you run func init, you only have the Event Hub trigger binding. The dapr binding I added later, but we'll see how we do that in a moment. Now, the thing is, of course, that when you create your Azure function on your local machine, it will use, it will give you the basic Azure function functionality, but you will not be able to use dapr with it. So what you have to do is you have to go to host.json. That should normally contain what we call the extension bundle. You can remove that one so that you only have version 2.0 left. And then you basically just run this command, func extensions install, followed by all the rest, which installs the dapr components for use by Azure Functions. So that's great. But of course, I also need to have my Event Hub functionality still there. So as a second step, I modified this file over here, the extensions CS project file. I added a package reference to the Event Hubs extension, and then simply ran .NET build to basically rebuild this here and get me also the Event Hub functionality. So that means we're all set to use Event Hub, the Event Hub trigger from Azure Functions, and we're also set to use the dapr extension from Azure Functions. But then we have to update the bindings, where in the Azure portal you can do so from the portal and the GUI and so on. In this case, you'll modify the bindings in the function.json file here. So the func init command gave you this binding automatically, but of course with some defaults, and you have to change a couple of things. First of all, you have to change the name of the event hub. You have to provide some sort of connection string to connect to the event hub, of course. And you also have to provide a consumer group. I called it KEDA here because we're going to use KEDA in the next video to do some automatic scaling as well. That's not too important, but these three values need to be provided. Where do you get these values? Well, not that complicated if you worked with IoT Hub in Azure before. So this is an IoT Hub in Azure. The name is Geba Hub. So we use that name in our Event Hub name, as you see here. Event Hub name is Geba Hub. Then we need to have the consumer group. Consumer group is KEDA. I added that. If you want to add your own consumer group name, just click here, type the name, and then of course also save it, and you have a new consumer group. And basically a consumer group is used when a new application needs to consume this stream of messages. But then you have to also connect. Recommended to use the from the default policies, the service one, not the IoT Hub owner one, because this one has least privilege. That's of course the recommended one to use. And we just copy this from here. It also contains the access data. So that means that we now have our event hub name. We have our consumer group, in my case, just called KEDA. Then the connection string, yeah, I don't want to fill it out over here. This Geba hub here is a reference to where my secret value is. And the secret value locally is, of course, in local settings.json. That will not be new to you if you have worked with Azure Functions before. There you see the reference to Geba hub, and then we have what we copied from the portal, including the access key, or part of the access key that you see over there. Just a small note, you also see a value Azure Web Jobs storage. Yeah, in this case, because we're using the Event Hub trigger, the Event Hub trigger needs to store some metadata that it's using internally to make sure it works. Things like, for example, till when did I read the stream of data, checkpointing, stuff like that. So there is a storage account required to keep some data. In this case, this is just a connection string to a storage account on Azure in the cloud. Just create a storage account and put the connection string over there, and you're good to go. All right, so that means that we updated our bindings in function.json. So hopefully that means that in this case, the event hub trigger is working, and it gets the secret value from settings.local. But of course, I forgot one binding to explain to you, and that is the other binding here, which is the dapr binding. As you've seen a moment ago, we need to tell Azure Functions, look, you have to do PubSub to a topic. In this case, the topic is called alert. You need to send this message. Well, indeed, we have to tell Azure Functions and to use the dapr subsystem to do this. Now, that's what we're doing here in function.json. We are adding a binding called dapr publish. The direction is out, and the name of the binding is alert. Now, the name is the same as my topic name, but it doesn't have to be. It can just be a generic name for your binding, and then your topics, you decide what your topics are in your code. So in this case, it could be a little bit confusing, but just remember, this is the name of the binding, and later we'll have also the topic name, which is also alert by coincidence. And of course, this thing here, what you see here, this dapr publish, was only made possible because we indeed did the installation of the dapr extension in Azure Functions. Otherwise, Azure Functions would not recognize that. Great. So that means that we can retrieve data, have input data from an event hub, and we can send an output via dapr to a topic, which is the alert topic. In code, what does that look like? Well, of course, very simple, because we have these abstraction models of Azure Functions and dapr. It means I don't really have to know anything about event hubs. I just use the Azure Functions model to work with those messages. And I don't really have to know anything about PubSub with Redis or Redis streams, because dapr is hiding that for me. So we have a couple of levels of abstraction going on here, which make it easy on the code part. which will probably make it a little bit more complicated on the plumbing part, but that's okay. And here we have now the code that makes this all work, which is of course prototype code, right? It's not production ready code. So what we get is the following thing. Of course, when the function is called, there's a context. The context gives us access to the bindings, as you'll see in a moment. The second parameter is basically an array of messages that comes in from the IoT Hub. That's basically how the Event Hub trigger works. So we loop through all these messages with a for each loop. Then we just print out every message to the screen. That's fine for now, just the context.log. Now we check if the message temperature, so it's a JSON, it expects a JSON formatted message with a temperature field. When the temperature is over 29.5, we have to send an alert. And the actual sending of an alert, which we know is we send a message to a topic, and we use the PubSub functions of dapr. That's just this, because we have the binding alert. Remember, from function.json, we have a binding called alert. We use that binding here with context bindings.alert. And then we have to, according to the documentation, you can find it all there, we have to set a payload, which will be what will be inside our PubSub message. And of course, also the topic needs to be described. So when other applications or services subscribe to these PubSub messages, of course, they have to also say we are interested in the alert topic to get these delivered to them. In this sample, I don't have that code written. We'll just take a look in Redis in a moment if there are messages in a Redis stream, which is called alert, to check if this is working or not. So this is a very simple code, which should make everything work properly. So now we have to keep our fingers crossed, of course, and we have to run the Azure function. Now we cannot run the Azure function just with pressing F5 like you normally do. You can't do that because you have to run it within dapr. The dapr system has to be available to the Azure function to be able to use dapr functionality. In Kubernetes, that will be done with a sidecar. On Windows or Linux, you just run the Azure function with dapr. So we use the dapr run command for this. Actually, I don't think I need the port 7071 there in the end, but that's okay. It doesn't do anything for the sample here. So we run this this command, and what's happening now is it says you're up and running. So dapr is started, but also your Azure function is started. So if you do logging from the Azure function or logging from dapr, we'll see it here and appear here as well. Yeah. Let me just check if everything is correct. No, that's not correct. So we're going to go to, and that's an important one, we're going to go to this folder. So we're going to open this in the terminal and then again run this command. So of course we have to make sure that we run the correct Azure function here. So the Azure function is now run. This one here, process messages. And yeah, let's hope, let's see if we can get a message in our system. So I have an IoT Hub here. The IoT Hub has a couple of devices. I can send a text or a message from that device. Now, actually, I had a device which was called Keda, so I'm going to use this one. I'm going to send a device to cloud message. And by the way, this is the IoT Hub extension for Visual Studio Code, which makes it easy to interact with IoT Hub from within VS Code here. We're going to send a message. We're going to only send one. Every 1 second, that's okay. We're going to use a data template. We're going to delete this one here, and we're going to provide something that our code will understand. So I'm going to say here, well, the temperature is 29.8 degrees. Couldn't be simpler than this, of course. And we're going to send this message to the IoT Hub in the cloud. And in the bottom in our terminal, we should see that the message is picked up and that an alert has been sent. That's an important one. An alert should be sent in this case. So let's check it out and see what happens. And indeed, our trigger resulted in a Azure function call. We processed a message, this one of course here, with 29.8 degrees, and we also sent an alert message. Now it's a bit difficult for me to verify if the alert was really sent, so it should be sent to a topic within, to a topic which is basically a Redis stream. So let's check if we can, that's the wrong window. Let's check if we can find out if this properly works. So let's do a docker exec here, and we'll exec into the Docker container, which is Redis. And I didn't do this correctly, so let's remove this. Double click, right click. Oops, doesn't work now. Okay, then we do Control C, Control V. No idea why that suddenly stopped working. That's fine. Yeah, here we go. Alrighty. And then start our shell inside the Redis container. We can start the Redis CLI. There's no authentication here, so I don't have to authenticate. When you deploy Redis in a cluster or on Kubernetes, you normally will have some kind of authentication happening. We don't do that here. Let's get the keys. No, that's not correct. It's keys and then a pattern. And as you can see, there's a key which is called alert. Remember, I did a dapr init a while ago, so it actually put a new container of Redis, an empty one, on my system. I didn't create this key myself, so it must have been created by dapr when we were sending the PubSub message. Now, this is not a simple key value pair. This is a stream, so I have to, of course, know how to read the stream. You can use xread for this. Xread takes then the streams parameter and then the key, so the name of the stream, which is alert. And then, yeah, we can also specify here an offset where do we want to read the stream from. I'm now saying start from the beginning, which results in the following one here. So this is the actual message that was sent. I think it's the cloud events specification. And as you can see, there is some notion here of dapr, and we also have our data field, and that's the I don't care about the actual value. It's too hot. Basically, is what I sent from the code. Well, let's see if we send a couple of messages. Like I'm sending 5 messages. Let's see what happens. So 5 messages are being hopefully successfully sent. Yes, that looks okay to me. And then let's see how many that we get here now. Yes, we have 6 messages in total. So we clearly see that the sending or the publishing of a message to a topic called alert is happening. Now I just need to have some other application that subscribes to this topic and then does something with the alert messages. I didn't do that here, but you see that the messages are ending up in Redis without me having to know anything about that, basically. So just the function.json specification, and then this simple code where I'm doing the PubSub from this code over here. That's all that it took me to write this message. So that means you have seen how this flow is working. So to conclude, we basically use 2 different programming models: the Azure Function programming model, and then something called dapr. Azure Functions makes it easy to write event-driven code. So in this case, we use Azure Functions to make it simple to read from an event hub and to get our IoT data. And to also hide the complexities of working with topics and web subsystems and so on, we use the dapr subsystem to do so. And because of the recent integration of Azure Functions with dapr, we can make this all work together in one example. Now, this was of course all on my local machine. We'll have to get this to run on Kubernetes as well, of course. What do you think? But that will be for another video because this one is quite long already. So hope to see you in that video as well, more or less. Yeah, take care and see you next time.